Good morning, everyone. Hope you are doing well. This is Ms. Pamela giving the physics course for grade 10 American System. Today we are going to start with chapter 19, section 1, electric charge. If you can all please open your books on page 675 so you can follow up with me. First, we are going to define electric charge. Electric charge is the physical property of matter that causes it to experience a force when placed in an electromagnetic field. So if an object has a charge and it's placed in an electromagnetic field, it experiences a force. We have two types of electric charges. First, a positive charge and a negative charge. The electric field lines come out of a positive charge and they come into a negative charge as shown in the figures in front of you. Interactions between charges. There are two main interactions between charges. First, attraction between unlike charges. When there is a positive and a negative charge near each other, they attract each other as shown in the figure in front of you. And the electric field lines connect with each other. The charges come out of the positive and into the negative charge. The second kind of interaction is repulsion, and it occurs when two same charges are near each other. So if we have two negative charges, as shown in the figure to your left, we will have repulsion. And also if we have two positive charges near each other, also we will have repulsion. As we can see in the figures, in both cases, the electric field lines repel and move away from each other. The only difference is that in negative charges, the electric field lines come into the charge, while in positive charges, the electric field lines come out of the charge. Electrically neutral objects. Electrically neutral objects are objects with zero total charge. Most everyday objects are electrically neutral because they contain equal amounts of positive and negative charge. So whenever we have an electrically neutral object, the amount of positive and negative charge inside of it are equal. Atoms have positive, negative, and neutral particles. The negatively charged particles inside atoms are electrons. The positively charged particles inside atoms are protons, and the neutral particles inside atoms are neutrons. You can see in the table in front of you the symbol for each particle, the mass for each particle and the charge for each particle. You are responsible to know these values in order to be able to solve the problems and the exercises we have in this section. Note that the proton and neutron each have about 1,000 times more mass than the electron, so they are much heavier than electrons. If the atom has the same number of protons and electrons, it is electrically neutral. So, as we might conclude, if it has more electrons, it will be negative, and if it has more protons, it will be positive. Also, we have to know that charges are measured in coulombs. The unit of a charge is coulombs, designated by a capital letter C. Charge quantization. Since electrons always have the charge negative E and protons always have the charge positive E, it follows that all objects must have a total charge that is an integer multiple of E. Thus, the charge on an object can be positive or negative E, positive or negative 2e, positive or negative 3e, and so on. But it is never a decimal like 1.5e or a negative 9.38e. So the charge of objects is always an integer multiple of e, and it's never a decimal. It will always be a whole number. Because we must conclude that we cannot have half an electron or quarter an electron or a proton in an atom. Example, find the amount of positive electric charge in two helium atoms. Hint, each helium atom contains two protons and two neutrons. To solve this problem, first we write the given. In the given we have that the helium atom contains two protons, which we know are positively charged, two neutrons, which have no charge, and they are asking about the charge of two atoms. So first we find the charge of one atom, and then we can find the charge of two atoms. If each atom contains two protons and two neutrons, then we have to calculate the charge of the two protons because the neutrons have no charge. So the charge of one atom is 2 times the charge of one proton, which we must know as 1.6 times 10 to the power minus 19 coulombs. So the charge of 2 protons is 3.2 times 10 to the power minus 19 coulombs. So this is the charge of one atom. They are asking about the charge of 2 atoms, so we multiply the answer by 2 and we get the charge of 2 atoms, which is 6.4 times 10 to the power minus 19 coulombs. Please, as a homework, do numbers 1 and 2, page 678, and numbers 8.9, page 682. Note that 1 mole contains 6.022 times 10 to the power 23 atoms. You need to know this information in order to solve some of the problems in your homework. Thank you and good luck.